Good afternoon, everybody. Hello from very cool Sarajevo today. Welcome to the next session where we'll discuss software development anti-patterns. My name is Mustafa Turaman. Here's also my Twitter handle. I work as a solution architect with Authority Partners. As I mentioned, I come from Sarajevo, from Bosnia and Herzegovina, but I work for Authority Partners, which is an American company. And last few years, I spent working with US enterprise companies, some of Fortune 500 companies, and designing solutions for them. I've been Microsoft Azure MVP for 5 years and recently awarded C# Corner MVP as well. Very certified in Microsoft technologies, over 50 different certifications, and been Microsoft certified trainer for, I don't know, 8, 9 years now. Okay, so let's start. But first, before we start talking about anti-patterns, let's discuss the little thing, what are the patterns? So patterns in software development are good guys, best practices that we want to replicate and implement whenever possible. So these are recognized good patterns that we want to replicate when project allows us. Opposed to this, we have anti-patterns that are basically complete opposite. These are the bad guys that we want to avoid at any cost. Like we don't want them happening on our project. A couple of words about the terms in general. So patterns started with patterns were started to be mentioned in the 1970s, and defined what are they and how to use them. For the first time, they were really detailed explained in a book, Design Patterns, written by Gang 4, that was published in 1994. Now, this book inspired Andrew Coing in 1995 to define the anti-patterns. And ever since we had them in software development, and we were discussing them and defining them. There are many of them, and let's try to figure out what are the main ones and how to recognize them. We can basically distinct them in few categories, few different groups. They can be organizational, management, design, programming, method, and configuration. It's not always clear which category specific anti-pattern belongs to, because they often overlap. Very often you will have programming and method overlapping, or organizational and management as well, design and configuration. These kind of fall all over the place and don't have necessarily to be categorized in single group. As I mentioned, there are many of them, and we will cover only a portion of them. The ones that are most frequently recognized, the ones that most frequently sneak up on us, and we will try to define how to recognize them and how to avoid them. So analysis paralysis is really often one that happens when individual, usually architect, or a group of people that is responsible for the design is over analyzing and overthinking. This usually happens in two cases. First one is when we have unexperienced architect on the project that is afraid she will make a mistake, and they are kind of stuck in the loop and trying to design a perfect solution so the project won't fail. Basically, it's not possible in software industry to have a perfect plan. Whatever we do, there will be hiccups and there will be issues. So spending an insane amount of time on analyzing and designing the solution is not a good practice, definitely, and we want to avoid it. So don't worry about it too much. Like, try to design the solution that makes sense. Try to ask for the second opinion from someone more experienced, but don't try to analyze every step you make and every decision you make, because it leads to failure at the end. Second one is a second pattern when this happens is when we have a group, when we have a project that failed previously, and everyone is in a fear that same will happen again. Same thing, overanalyzing every possible scenario will lead to nothing. Like there are always unpredicted things that will happen during the project, and we need to create a solution that will work, but some adjustments down the road might be needed. So it's perfectly acceptable, and don't spend insane amount of time over analyzing, overthinking, and questioning every move you make. Bicycle shed is basically giving a disappropriate way to trivial issues. The name itself came from the problem where group was assigned with the task to create a plan for building a nuclear power plant. However, they spent a very big part of both time and budget thinking about bicycle shed. So basically, bicycle shed is just a small, I wouldn't call it a building. It's a shed. So basically, a small shed next to the power plant where you would store your bikes. So they were discussing details like, oh, we don't want it to be like too hot during the summer or too cold during the winter. We don't want it to be in the sun all the time. We need to do this, do that. And by the time they decided how they want the bicycle shed, they figure out they spend a quarter of the budget for the complete power plant on it. So basically, you want to recognize the key components of your application, of your software, and you want to do appropriate weight among the issues and the components that you're working on. Design by committee is very often seen in enterprise companies, in big projects where we don't have one but several architects working. The problem is that with too many contributors and too many people having same weight to make decisions, there is no unifying vision. Basically, everyone is pulling in their own direction. Everyone is pitching some ideas and working around it. But as the end result, we don't have clear picture on what the software should do. Like, what is the overall architecture? How should it look like? It's acceptable to have several architects, but we can avoid this by appointing chief architect of the project that will oversee everything and have that final vision of how things should work. So basically, multiple architects can contribute to the project, but someone has to have a final word and has to have a higher overview of everything happening in software. Bleeding edge is a tricky one. It's cutting technology that is still untested and unstable. Everyone in IT industry want to work with cutting edge. It's something we are drawn to. Like, everyone wants to use latest and greatest, and it's perfectly fine. We want to use best technology available to us to create best possible product, and that's a perfect fit. However, very often we fall into the trap that we are working with latest technology that is not fully developed. Like, we don't have a fully supported version, or we are using something that is still in the experimental phase. That is fine for working on our side projects, like trying out something, having like a personal project that we want to create. If we are discussing like the paying application, something that brings food to our table, it's really bad idea to use something that is unreliable. So try avoiding technologies that are still not fully tested. Try creating proof of concept or something else before deciding that you actually want to use latest technology that you haven't used before on a project. Code thinker, again, something very often seen in enterprise, is basically part of the system that no longer had any use. However, no one is really sure if it can be removed or what it actually does. So as final result, we have a situation that piece of software stays there, like piece of code is inside our application, and no one actually is using it. We're wasting resources and so on because of uncertainty. Again, as I said, very often found in enterprises, especially in legacy projects, where code was developed for many years, and a lot of people went through the project, left the project, new people came. So it's often seen that certain components no one is really sure about. Just basically try things out. Like there's no guarantee like that something is necessary or not. The only way to make sure is actually to remove it. Of course, you don't want to do that in production, but try working on the lower environments, seeing what happens if you actually remove it and what will happen. Basically, what you have, the name says won't anchor, is just keeping you in place. It's like something that is not necessary, and it will help increase your performance, have better use of resources, and so on. Cash cow. Similar to the previous one, in certain terms, it's a profitable legacy product that basically leaves us in our comfort zone. As a result, we become complainants, and we don't actually like invest in something new. These kind of products are a good thing. They're bringing a lot of money, and it's cool to have them. However, we have to think about what will happen, because every software has a expiry date. Like everything that we create has a certain limit. It will at certain time become uninteresting to users. So basically, there are two ways how to pull out of this. First one is try new ideas, like try invest in creating something new, creating new applications, new products that you can offer, try work with new ideas. The second one is try investing in that particular product. Having the cash cow bringing a lot of money, that might be also a good decision to think about how you can improve it, like how to modernize it, how to include new features, new capabilities, and so on. So we definitely don't want to just have keep it as it is. It's certainly nice to bring in money, but we need to think about new ideas and what will happen in the next iteration. Cart before the horse is a particular anti-pattern where we are focusing too many resources on a stage of a project out of its sequence. So basically, this is a lot about planning and how we want to how to create a flow for development, basically having a proper sprint planning and everything else. We don't want to invest a lot of time on a component that might not be used in next, I don't know, 4, 5, 6 months or even longer, depending on the size of the project and everything else. This happens very often when we have like small components, like when we are, especially when we are doing microservices and everything, and we want to have something finished. So basically, if we have a component that is easy to finish, we might throw our work right at it because it's something deliverable. It's something that we can complete and say, okay, this part is done, we can move on. However, if that specific component that we're working on is not going to be used by any other service for next 3, 4, 5, 6 months, we really want to rethink what we are doing. So basically, we don't want to focus the resources and our capacity on things that will not be used immediately. So try to have a structure and think about, especially when we're talking about agile, DevOps, and everything else that is popular in the software industry these days. We want to think in terms of MVP product, that we want something deliverable, something that we can show people how it works. So basically, component that is not used by anything for a longer period of time is not the way to go. Escalation of commitment is failing to revoke a decision when it proves wrong. This is very often in software industry in general. I've seen this one very often when we have an architect and we have a big ego, and it's usually how it works. So people are designed like making a decision and they're sticking with it. And they don't want to accept that they might have made a mistake, and that kind of creates a worse situation than it actually is, because if we recognize that it's a mistake, we made a wrong decision, we need to turn back and start from like rebuilding something. What usually happens, people are not accepting it, they are sticking with it, trying to pull out of it and prove that they were actually right. And it usually leads to a situation that we spend even more time on trying to remove that mistake, trying to fix it, and basically fail at the end and then have to move to the start again. So basically, you don't want to drag it on for infinite amount of time. You actually want to recognize when decision was bad, and you want to return to the point where you can actually fix it. So don't hesitate to actually do that, because failing to do so might lead to failed project in the end. Micromanagement. Okay, this is the ugly one, and unfortunately, very often one. I don't think that I've had a contact with someone in the IT industry that didn't had a introduction to this. So basically, it's insufficient results stemming from excessive supervision. It's basically where our boss is overseeing every possible move, not allowing people to make any kind of decision, no matter how trivial they might be, questioning every move, every suggestion that someone has, and not allowing people any kind of expression, any kind of like creativity whatsoever. Basically, there's no fix for people doing so, like for the managers. I'm really sad to say so, but I've seen many of them over the years, and I've tried working with them, I tried discussing the issues and so on. However, the only solution I found so far for a situation like that is to leave. Someone has to leave. Either you leave the project or manager leaves. It's not a good situation, but it's not something easily fixable, and in matter of keeping everyone on the project. Micromanagement is when management, again, management issue. Micromanagement is when management is keeping employees in the dark. Basically, this happens very often when we have a startup and management is having investors working on the MVP and everything, and employees are not aware of the situation, where the company stands at, what is going on. This usually leads to really ugly situation when project fails and everyone's is like, yeah, we're out of the, we don't have a job for starting Monday. It's not easy to fix because you are usually not aware of it until it's too late. But basically, if you don't have any kind of information what is going on inside the company, if you don't know where you stand, how your finances work, and management is not sharing anything with you, it's probably not a good situation. So basically, try finding out, try talking to people in charge, getting some information. If they're keeping it, it's a really probably bad situation, and try to have a backup plan, an exit strategy if things go bad. Seagull management. Okay, from the image, I think it's probably pretty clear what it is. We have certain type of managers don't interact with people, with their team, until things go wrong. Like if something bad happens, they will be in there and they will crap on everyone and then leave again. So basically, a really bad situation, usually followed by the things like if everything is good, then manager is responsible, but if things go bad, then team is responsible. So it's similar to micromanagement. Either you can talk to your manager, supervisor, or you can leave. It's not something that it's a character, and that's easily fixable. Peter principle is, I keep saying this, but another one very often recognized in enterprise companies, and it's rising to a level of incompetence. So basically what happens is that because someone was really good at one position, they keep being promoted even they are not a good fit for the next level or for the next position. I've seen this very often when like we have a senior developer very good at their job, and at a certain point they decide that they want to go with either architect or management position. It sometimes proves wrong. Like a really good developer, amazing developer, might not be a good fit for the architect position. It doesn't open very often, but they might lack that self-esteem and that drive that makes architect a good architect. Knowing software and knowing how to write code is not the only characteristic of a good architect. You have to have management skills, you have to draw different things, you have to understand the business side of application and so on. So basically, that step sometimes is not a good one for the person. Same thing for the management. I've seen, and this one I've seen more often, is when a really good software developer moves to a management position and they figure out that their people skills are not as good as they thought. They are good with their team, discussing how to do application, how to write code and so on, and they might be a good team lead or whatever, but moving them to complete management, putting them out of the technology and just managing people proves a bad move more often than it doesn't. Silos. This one is organizational, and basically it creates a situation where our teams are completely isolated from one another. Basically, we have a situation that we assign teams to different projects, different applications, and they work on that and they communicate only with their own team, never discussing anything with anyone else on the project and so on. This creates a lot of issues when we want to replace people. It also creates a lot of issues when we have a large product and need to bring people together, because it creates a situation of mistrust. It creates a situation of people not accepting that they need to work with someone new. And it also creates a communication issue when we have a team that need to communicate with each other, because usually the silos means that they are not communicating directly, but through the higher chain. So basically, any discussion will be led through managers rather than the team themselves. Group thinking, similar to previous one and really connected to this previous one, is when we have a team working together for a long time and somehow they start thinking alike. They are in time, they unwillingly and often unknowingly completely start thinking the same way. They accept same ideas, they accept same way of doing things and so on. This creates a lot of issues when this team needs to work with another team, because they are rejecting any kind of different approach or anything else. It also creates a major issue when a new team member is assigned, when someone new joins, because they're shutting any possible idea that is not acceptable to the group right away. It's like you have a really good idea, you propose to the team that has a group thinking, and it will be shut down because they don't do that way. That's the only explanation you get, basically. It's not because it's a bad idea, it's because we don't do it that way. So you probably want to shake things up in this case. You want to rotate people, like having a good team working together for a long time is a good thing. Like you have a reliable team that knows each other, and they are probably good together. They will more easily work when the deadline is tight. They will have good communication. They will help each other. They have this situation when you have a solid team is really good on several levels. But however, you want to shake things up in terms of like moving particular members to other teams occasionally, like just like moving someone for a month or two to do something else outside of the team, just to give them other way of thinking, like to see how other people work, how other projects work, and accept new things more easily. That March, basically everyone worked on a project they were sure it will fail in the end. It's a really ugly situation when you are working usually overtime because everything is behind the schedule, and you know that nothing is going the way it should, and you're never going to do that deadline, and basically you just keep working without any kind of motivation or basically end result is really bad code, because you don't really have any passion about what you're doing. You are just doing it to punch the hours and complete what is asked of you. But if you are working on something that you don't believe in, it will definitely fail before it even started. Brooks Law is really connected to the previous one. Like usually when you have a project that is behind the schedule, people are already fed up with the overtime. Everyone is sick of everything. And the management decides that they want to do more, to add more resources to the project. Now, this is where Brooks Law comes in. Basically, adding more resources to increase this velocity is not possible. For example, if we have 7 people on the project, we have 21 lines to establish communication between everyone on the project. So to have everyone talking to everyone, we need 21 lines. It's a lot of work to communicate between people. Like to have everyone on the project to talk to each other, it's a lot of work. Now, if we are adding more people to the project, and we had only 4 people, we have 11 now, it takes 55 lines to establish a good communication. So it's a major escalation in that. What management usually doesn't recognize is that while adding the resources, you're taking from velocity of the current team. So we have 7 people delivering something, and we have 4 more people added to the project. Usual velocity, usual delivery from original 7 people on the project will significantly drop in next couple of weeks, because they are using a lot of time to explain people that are new to the project what is going on, how they can do that, how this works, what is the idea behind that, why did they do this, because why did they do that, and so on, so on, so on, so on. So basically, adding more resources to the project is acceptable at a certain stage, but when we are behind the schedule and deadline is closing, adding more resources is usually a really bad idea. This usually is followed by the joke like PM is a person that believes that 9 women can deliver a baby in a month. So basically, this is how it stands. Like if we decide to go with more people at the beginning of the project, then velocity will be something. But if we have a certain number of people and just keep adding people to the project, everyone velocity will drop down. So basically, total velocity will be less, and it will not be growing proportionally. Scope creep, very often one. I don't think I worked on many projects when this didn't happen. So basically, scope creep is adding new features to project after the original requirements have been accepted. And today, everyone wants to work agile. Agile means things change and so on and so on. But basically, usually that is excuse to pile up a lot of new things that we think of in time, because at the beginning of a project, client usually is not 100% sure what they want, and they decide to add certain things only after portion of the application is done, and then they start getting new ideas and so on. But basically, what we have to keep in mind in this one is the iron triangle. So basically, we have time, scope, and cost. And basically, these are affecting the quality of the final product. It's impossible to increase scope and not increase time and cost and have same quality. So basically, if any of those are changed after the original requirements are done, adding to the scope actually means that we need to increase cost and time for what we are delivering. So basically, always keep in mind, don't accept any change until you change timeline or cost. I would prefer a timeline, because cost is actually related to the previous ones, that you can add more resources and so on. So basically, the perfect idea is, if you're changing scope, try changing time of delivery as well, because adding new items on top of the original estimate will affect everything. Over-engineering is making a project more complex than it actually needs to be. This one is usually found when architects work on a large enterprise product for a long period of time, and they are expecting unpredicted scenarios and unpredicted things to happen along the way. It doesn't really need to be like that. Look at the requirements, analyze what is asked from them, and not try to analyze everything and try to predict every possible scenario that might happen down the road. It might never come to that, so just basically cut it, do what is required, and if new requirements come along that may complicate things more, then address them accordingly. because you're just creating you're preparing yourself for scenarios that might never happen. Over engineering is also very connected to overthinking, over analyzing. So try to complete what is required, what are the original requirements, and creating a solution for that, and not creating something that will be base for everything else. Okay, gold plating is continuing to work on a task without adding any value. This one is very often found with unexperienced developers when they want everything to be perfect. Basically, they already they saw the requirements, they completed the task to fulfill the requirements, but they keep adding things that they might consider cool or good to be added. It's not basically you're wasting time on things that might not be needed in the end. So basically, because we are considering something cool and something interesting that we might add, it might not be interesting to our end users. So basically, try completing the requirements and then stopping, because adding something that is not required is just basically wasting time without adding any particular value to it. Smoke and mirrors is found in two cases. So basically, it's demonstrating unimplemented functionalities as they were implemented. I've seen this in two occasions. First one is when developer did not finish the task, and they are trying to buy more time, and they are presenting it usually with some hard-coded things, just to show that it works in one simple scenario. But basically, they are trying to buy more time because they didn't complete, and then usually things get more complicated. They are trying to finish that, but fall behind on the new tasks and so on. So it's like a bottomless pit. You're just drowning yourself in a quicksand. The second one I've seen this is when usually with the startups, when management is trying to impress investors, and then they are showing things that are not completed as they are completed. So it's also not very good idea, because it's built on a lie, and very often you will fall into that trap. You might, for certain functionalities, you might give up on them, or decide they are not possible as you imagined them, as you originally designed them. So basically, giving this idea that something is complete that might not be in the application in the end is a lie that you might be caught in. So give it up. Big ball of mud is when we have a situation when the system has no recognizable structure. Again, big projects, often enterprise, often legacy, where we have a situation that for a long period, code was developed for a long period of time. It was just added and added and added. It's impossible to recognize what is going on in there. You don't have any kind of structure. It's just call after call without any kind of possible logic, and it's impossible to maintain. It's very hard to debug, and almost impossible for a new person to join the project, because it takes months to actually get involved and understand what is going in there. Lava flow is keeping a bad code because removing is too expensive, or might have unpredicted consequences. Very often followed or similar to boat anchor. It's basically having a bad piece of code that we are completely aware of, so we know it was badly written, but we don't have time to actually fix it, or basically if we remove it, we don't know what will happen. as I said, it's very similar to the boat anchor, a piece of code that is there. It's a lot of weight. It's dragging us with it. So we want to either remove it or replace it as soon as possible. Spaghetti code is very similar to the big ball of mud, where we don't have recognizable structure. There is some, we can recognize some patterns, we can recognize some flows inside the application itself, but it's really all over the place. This one usually happens in big projects dragging on for a longer period of time, where there was a lot of contributors, a lot of people went through the project, and everyone left a piece of them there. So basically, again, not an easy situation to deal with, and it requires a long period of time to actually change things around and create more structures, because you have to redesign, change things piece by piece, considering every possible scenarios. It requires a lot of testing, a lot of patience to actually understand everything, to decouple components, and to create something with more structure. Lasagna code is similar to this one, but in this situation we have too many layers of inheritance. So basically it's a call depending on the call, depending on the call, depending on the call, and so on. And basically this is a situation where we have a situation that too many layers and too many inheritance is embedded. So basically too many inheritance means a bigger chance of failures and bigger chance of errors, because if one of the layers throws an error, we have a too long of a chain of execution, and if any single one of them times out, the application goes down. So something we want to avoid at any cost. Abstraction inversion is when we implement functionality but never expose it. Basically, it's creating a piece of code that executes on its own. It's completely, how to put it, best way possible is to reuse code whenever is possible. In abstraction version, we have code repeated over and over and over again, because we are never exposing the methods. We are always executing pieces of code in a single environment. Basically, we want, once we create certain functionality, we want to expose it and call it whenever possible. This way we are avoiding code repetition, and we have a cleaner solution. Circle dependency is when we have a lot of models depending on each other. This is again a big performance issue, because when we have a package A depending on the package B that is depending on the package C, and C is again depending on something else, we have too many dependencies. As any of them, we have a big chain of execution and too many dependencies. So similar to lasagna code, if any of the layers in this situation, any of the module fails, everything fails, the structure collapses. So basically we want to avoid a situation like that. God object is also referred to as an object that knows too much or does too much. Is basically when we have too many functionalities in a single part of design. We are basically creating a bottleneck that can collapse everything. So we are having a single component in our application that everything is designed around, and basically if that component goes bad, if something fails there, everything else fails. So basically, again, situation that we really want to avoid when possible. Poltergeist is an object that has a purpose to pass information to another object. So basically, we are adding unnecessary layer in this situation, because we are creating object on its own that just collects information, passes it along. Best possible solution is, if we need to pass information from one object to another, just do it directly from one to other. No middleman in that situation. Easy waiting is when we have a situation when our resource is consumed while waiting to something to happen. Basically trying to create a logic when we are constantly trying to fetch information. It's a really bad design, because when we are constantly checking if something is happening, we are wasting resources most of the time, because we are constantly checking, we are constantly checking, we are constantly checking, we are constantly checking. Okay, here it is. We are creating a situation when we are trying to get information, asking everyone what is going on, if there are any inputs and so on. It's a situation that we want to create, is that we have an object, information comes along, and we process it. We don't want to spend resources unnecessarily, and we want to have a better messaging system implemented in our solution than fetching information all the time. Coding by exception is a situation where we are adding code to handle each special case. So basically, we had our initial requirements, we created a piece of code, and then we got the first exception. And we added some new code to handle that specific exception. Then the new exception came along, and then we added new piece of code to handle that one. And for each next exception that we got, we added new piece of code. Basically, what we're getting in this situation is too many layers, too many inheritance, and we want to avoid this when possible. So basically, once you get down that road, and it's easy to get there, because okay, you designed it, then first exception happened, you handled it, second one handled it. Now when third one happens, you want to rethink of what was done so far, and rewrite that piece of code to address everything at once, not to have each special situation handled separately. Error hiding is when we are hiding errors or returning meaningful messages. This happens in two situations. First one is when people are trying to hide bad code, and then they are hiding messages, and it creates a situation that once it goes out there, it's possible to debug, it's possible to understand what's happening, and it takes time just to remove that hiding error situation. Second one is when we are not returning any meaningful messages and users are clueless on what's going on. For example, like when someone tries to fill a form in our application and they are not allowed to continue because one single piece of information is wrong, we want to point out what is wrong. We don't want to create some meaningless message like something went wrong. You want to point user in the correct direction and tell them what was wrong and what they need to fix. Hard coding is embedding assumptions into implementation, basically adding any kind of variables to code. So basically creating a situation that changing a business logic, like changing something very basic, like a price of item in your database, is fixed inside the code and not in the database itself. So basically, that you have to address any kind of small change by changing the code itself. It's basically adding information inside the code that should not be that are basically changeable at any possible time. Soft coding is opposite to that one, is basically storing business logic in configuration files rather than the source code. So basically another situation that we want to avoid, because It's hard to keep track of the configuration things, what's going on in there and how to handle it. And usually people are having hard time to remove situations like that. Cargo programming is a situation. Okay, so this one happened, like the term itself comes from a situation when during the World War II, US Army landed in a small island in Pacific Ocean, and the natives were so overwhelmed by them and in awe by them that they wanted them to come back as soon as possible. So they tried to build planes and cars and different things out of wood, so they would attract them to come back. So basically, the term is using a method without or pattern without understanding why. This is like applying patterns to our code without really understanding why what does this pattern or method does. So we want to actually, patterns are good, but if applied properly, we want to understand why is this pattern good and why we want to reuse it, why do we want to apply it here before actually applying it, because good pattern applied in a wrong way becomes anti-pattern. So copy and paste programming, I guess everyone should be familiar with this one, but basically it's copying existing code rather than creating a solution. Nowadays, people are not only copy pasting their piece of code, they're copying everything they can pull off the internet. And it's fine to reuse things. It's fine to reuse pieces of code that are written either by you or by your colleagues or someone else. But what you want to do is understand what that code does. So basically, if it helps you resolve your issue and you can understand how it does, then it's perfectly okay to do it. But you don't want to just blindly copy paste something. How does that joke go? So basically, what is the biggest problem for developer today? When they copy paste the code, they were not sure if they copied it from the answer or from the question. So there it is. Golden hammer is assuming that our favorite solution is always applicable. So all of us during years develop like affinity to certain tools, so certain solutions, so certain frameworks, certain methods, and so on. It's okay to prefer something over the other, but you want to reconsider what you're going to use based on the requirements and what you need to complete. So basically, if I prefer using .NET for everything everywhere possible, but if I want to do large data processing and data manipulation, like .NET is not probably the way to go. I would probably go with R or Python or something third. So basically, consider the tools. Like we all have preferences, but don't go blindly follow your favorite things. Like there might be better solutions for what you're trying to achieve. Dependency hell is a problem with versioning of required products. Also is similar to DLL hell or jar hell, where we have a lot of dependencies inside and it's impossible to track down everything and know what depends on what. Try doing a clean solution, try to redesign, redecouple. I know that is like a serious investment. It takes a lot of time to actually see what is going on and try to fix things piece by piece, but in the end result is worth it. So finally, these are only few of the most common anti-patterns that happen out there. So basically, there are many of them more. They are just waiting to hit you. They are just sneaking behind the corners, waiting for you to start a new project and then to creep up on you. I recommend the book about anti-patterns written by upcoming Gang of Four. So try looking into that and try looking into more anti-patterns that might help you recognize them in time and try to handle them in timely manner. Thank you, everyone. Are there any questions? Okay, I guess not. In that case, thank you for your time today. I hope you enjoyed session and learned something new that might help you tomorrow. Goodbye.